Okay, this is our third lesson. This is Unit 5, Lesson 3. And in this lesson, we are going to learn about addition and subtraction. Now, it's almost counterintuitive to think that, like, the level of difficulty. You would think that multiplication and division would be more difficult than addition and subtraction. However, in the world of fractions, this just isn't the case. Addition and subtraction is more difficult. Okay, but the one rule that you have to follow when you're adding and subtracting is the denominators have to be the same, or also known as common denominators. So in a simplistic view, if I have a division of 4 and a division of 4, that's exactly what I'm looking for. Okay? A division of 4 and a division of 4 is exactly what I need and have. And after that's accomplished, the answer is 4. So you don't actually add the denominator. All you do is you generally add the numerator. Okay, so that's how that process works. So you have to get a common denominator. If you don't have a common denominator, I will teach you how to obtain it from something that doesn't already have a common denominator. Second note is if you do have a subtraction, okay, if you do have a subtraction, what I encourage you to do is turn it into an addition. How do you do that is, well, you just slap a negative on to the numerator right here. And again, we'll go through several examples in which we have to do that. Okay, so here we have 2x plus 3, x plus 1, 2x plus 3, 3x minus 8. Okay, notice right now we have a common denominator. So restrictions, opposite number over letter, -3 over 2. X can't be equal to -3 over 2. And notice how it's the same right here. I hope anyways. So there it is. Okay, so but now that I have a common denominator, that denominator is 2x plus 3. Okay, it's just what it is. And all I do is I add and subtract the things that are in the numerator. So the x's are x plus 3x, and the numbers are 1 plus -8. There you go. Okay, so first and foremost, I check out my denominators. They are the same. Sweet. This is a minus, so I'm going to turn that into a plus and just kind of switch the sign of any numerator that is there. Okay, but since that the denominator is the same, excellent. The answer's denominator is going, oops, sorry, restrictions. Sorry, restrictions. X can't be equal to 0. X can't be equal to 0. And, okay, so here we have 3 plus -5, which is -2. And then again, if you can simplify or anything, do that simplification. Okay, right now the restriction, oh, sorry, let me write it a little bit more formally. Okay, so right now restrictions are x can't be equal to 0. Okay, good to go. Now, but notice how we do not have a quote-unquote common denominator in this problem. Okay, so we've run into our first problem, which we don't have a common denominator. And so now what we need to do is we need to create a common denominator. Okay, so how that occurs is I get to multiply by anything that I want to make this happen. Typically, what happens is you multiply each denominator by the other denominators. Typically, that's what happens, all right? And that's what's going to happen in this one. All right, so I need to get this left-hand one needs an x squared, and this right-hand one needs a 2. So I multiply by an x squared on the left and a 2 on the right. But I can't just multiply just a denominator. Technically, you have to multiply both the numerator and denominator by that thing that you need to put on. So, excuse me. So by doing this multiplication, I now have a common denominator. Okay, so this side is 2x squared. This side is 2x squared, as far as the denominator is concerned. And so my common denominator is 2x squared. Now let's see what else I have. So the numerator on the left is going to be x squared times 1, so that's x squared. And the numerator on the right is 3 times 2, which is 6. Nothing can be simplified, and so that would be your result with your exclusions of x can't be equal to 0. Okay, let's get some restrictions. So x can't be equal to -4. Again, if you see a plus or minus, think of it kind of like as a grouping, right? So think of a plus and minus as kind of a grouping. All right, so we need a common denominator. They're not the same. So we multiply by the other. This right-hand side needs a 4. The left-hand side needs a 4, and this right-hand side needs an x plus 4. All right, so that makes our grand denominator 4x plus 4. Okay, that makes our denominator 4x plus 4. Let's see what we have here. The left-hand side is 4 times 3, which is 12. The right-hand side is x times x times 4, 2 times x, and 2 times 4. Or AKA, they multiply to 8 and add to 6. So this is plus x squared plus 6x plus 8. And so doing one little minor cleanup step, this numerator is x squared plus 6x plus 20. There it is. Okay, this right-hand side needs an x. Left-hand side needs an x plus 3. But before I move any further, restrictions are x's can't be equal to 0. X's can't be equal to -3. But I've established a common denominator, which is x plus 3. And this left-hand side is 4x plus 12, and this right-hand side is -4x. Do a little bit of math with this numerator. And so 4x minus 4x is 0. And so I'm left with 12 over x plus Okay, so we're taking one more slight step forward. I notice that this left-hand denominator is technically x plus 1, x minus 1. Okay, so if I were just to blankly multiply this to the right, all right, it wouldn't make much sense for me to multiply an x plus 1. All right, so this is kind of like where you have to be a little bit analytical to get what your common denominator is. So the left-hand side requires the denominator to have an x plus 1 and an x minus 1. Outstanding. Okay, so I need an x plus 1 and I need an x minus 1. The right-hand side needs it to have an x and an x plus 1. So notice how they share some commonalities. They share a singular x plus 1. So when I am trying to accomplish this common denominator, truly, what does the left-hand side need that it doesn't already have? Oh, the left-hand side needs an x, and that's it. It only needs an x. Because now if I put an x, take a look at what that denominator is. It's x, x plus 1, x minus 1. What does the right-hand side truly need? It needs an x minus 1. If it has an x minus 1, then that denominator is complete. Okay. So restrictions before I take another step. X can't be equal to -1, +1, 0, and -1 again. Can't be. All right, so those are the restrictions. Okay, so let's take a look at what we have here. The denominator is now x plus 1, x minus 1. The left-hand side is x times 4, or aka 4x. And then notice how this is a -5 that has to get multiplied in. So this is going to be a -5x and a +5. -5 times -1. Clean it up just a little bit. This is a -1x plus 5, and the denominator stays the same. All right, so the denominator is going to be a +3, -3, and an x. So this left-hand side needs an x, and this right-hand side needs a +3. Restrictions are -3, +3, 0, and then again, +3 again, which I already have. Okay, x times x, 3 times x, 3 times 3. Okay, so the denominator is minus 2 plus 4. This already has a minus 2, so this side needs a plus 4, and that's about it. All right, so left-hand side is x minus 7, right-hand side is x plus 4. Oh shoot, I totally forgot to do restrictions, sorry. Was that positive 2 again? All right, so minus 1 has it, so this left-hand side needs a plus 1, and that's about it. So now the denominator is plus 1 minus 1. Okay, so again, don't forget that you're multiplying in. Anyways. Oh, restrictions. This is positive 1 again. So the denominator is plus 1 minus 1. And this is what? X squared plus 1x plus 3x. I don't know if they'll ask you to factor this at all, but you could. It won't really do anything, but the answer might be x plus 4, but it does, again, it doesn't simplify or anything, so that's what it is. All right, so x plus 2 and then x plus 2, so this left-hand side gets an x. Okay, so there's going to be some simplifications going on here. Usually you don't have to do stuff, but let's just take a look at what I can do with this answer. So what can I do with this answer? I can first take out a 2. But now I notice that I have an x squared minus 4, so that would be a plus 2 minus 2. Okay, so right now, I have a 2, x plus 2, x minus 2, all over x plus 2. So the logical simplification would be plus 2. And this would end up to be 2x minus 2 over x.